All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning about ESP32 Rust things. I'm hoping, actually, you know what? I'm going to try my best not to start off with a very long yap session. I don't think I have a whole lot to really get into. I did decide to go through. So I've been using WezTerm a lot more. Whenever I boot into Ubuntu on this same laptop, off of which I'm streaming to Twitch, I boot up Ubuntu. I load up Ubuntu. I load up WezTerm. Sorry. Whenever I boot into Ubuntu on this laptop, I load up WezTerm and do all of my terminal stuff there now, and I'm slowly going through. Oh, give me a second. Sorry. Um, I have Papa Mutt's stream on in the background, just to get some background sound. But yeah, okay. So I've been going through the tutorial slowly. It's not exactly a tutorial. It's more like kind of a tutorial. I can probably load the thing up here. Actually, let me switch to BRB real quick. Just real quick. Let's open up this and come back. Okay. Here, we are gonna go over to WezTerm, and under WezTerm, we should have, yeah. So this is the section that I'm going through: features, scroll back, quick select mode, copy mode, so and so, so and so, so and so. Finally, it goes into multiplexing as well. That is actually what I'm aiming for, but I haven't gotten to that part yet. There's a lot that I need to learn about this terminal. I don't know if their docs give all of the information, or I should say, I don't know if this section, if all of the sections within this section give all of the information about the inner workings of this terminal. I might need to go through the other sections as well. I've covered some sections of configuration, at least the ones that were relevant to me. I haven't looked into, for example, launching programs. Um, that should be interesting, by the way. I wait. Let me check that out real quick. Let me load this. By default, when opening new tabs or windows, your shell will be spawned. Your shell is determined by the following rules. On POSIX systems, the shell configured for the current user is the password in the password database will be used. The value of the shell environment variable is deliberately ignored in order for WezTerm to continue to be functional without restarting after the user changes their shell. WezTerm will set the shell environment variable to the shell that is resolved from the password database. If you want to control so and so, so and so, so and so. Okay, all right, fine. Changing the default program. Okay. So what this is saying, I'm guessing, is that instead of the shell, so I'm guessing what it's saying is that you are not limited to launching a shell. You could directly launch a different program. Though I'm trying to think of how you would be launching a different program without a shell. Let me just ask Gemini real quick. See, I said that I'm going to try not to make the yap sesh too long before we jump into the ESP32 stuff, but then now here we are. Okay. Hey, so I'm new to WezTerm. From what I understand, when you create a new tab, a shell is spawned within it. You launch your programs via that shell. What I'm wondering is, since WezTerm allows you to launch other programs than just the shell, is there such a thing as creating a new tab, and that tab will immediately load up a separate, for example, TUI program? Because what I'm wondering here is, like, how are we doing this without a shell? Okay, let's see what Gemini is saying. Welcome to the world of WezTerm. You've got the core concept down perfectly. By default, it acts as a wrapper for your system's default shell. However, WezTerm is incredibly flexible and allows you to bypass the shell entirely to launch a specific program. You can definitely create a tab that immediately loads a TUI program like btop, Neovim, LazyGit, etc. Okay. All right. Using the command line. If you are already inside WezTerm and you want to spawn a new tab running a specific program, you can use the WezTerm CLI. You can use the WezTerm CLI. Example, launching so and so, WezTerm CLI spawn. Okay, whatever. So and so tells WezTerm that everything following that command and its argument you want to run instead of the shell. Configuring key bindings, which is the automation way. If you frequently want a specific TUI to open with a keyboard shortcut, I actually might want that. I actually might want that. Yes, yes. You know what? I actually might want that. Um, Dude, I wonder if I could make my own little, like, shortcut menu kind of thing that pops up in WezTerm, and I can have my own. Actually, no, hold on. I don't need to make one. I'm pretty sure someone has made a plugin for this. I remember looking at the WezTerm plugins. I remember looking at the plugins list or the plugins repo, and one of them did mention something about launching programs or something like that. Give me a second here. Um. Okay. All right. So, I'm looking at the list right now. There's tab bar. There's session. Under session, we have faster way to search and attach to SSH domains. I should look into that. A workspace switcher with Zoxide integration. A simple and flexible way to initialize workspace configurations. I should look into this as well. Initialize workspace configurations. A WezTerm plugin to provide a simple and flexible way to manage and initialize workspace configurations. Let's see what this says. Oh, dude, I shouldn't get too, like, sucked into this. Okay, panes, pivot panes, stack. There's something Neovim related. There's something media related. There's key bindings. Um, Hold on. Tab, utility, send commands to multiple panes. I think that's the one I was looking at. I think so. I'm not sure. Um, yeah, I don't know. Okay, you know what? I'm not gonna get too sucked into this. Let me finish my question with Gemini. Okay, so I'm kind of confused here. I thought the terminal was running the shell, and through the shell, um, we could run various programs. How are these programs running without a shell? Or is it, I spelled shell wrong, shell. Or is it that the shell just provides um, um, just provides something that could um, yeah, no, okay, what is the shell providing then? Let's try and understand this, because I was always assuming that it's the shell is sort of so you have the terminal gives you the ability to, or the terminal emulator gives you the ability to give input and receive output, but that input is going to a shell, and the shell is then giving output, which the terminal, displays. But then, like, what is going on here? Okay, let's see. So this is a very common point of confusion. It helps to think of the shell as a middleman rather than the engine itself. Here's a breakdown of how programs actually talk to your operating system. The hierarchy of execution. In a standard setup, you have three layers. The terminal, which is WezTerm, that's the visual window that handles fonts, colors, and keyboard input. Then the shell, bash or bash, or let's say zish. There's also fish, which I found out is apparently Rust based. So that was interesting to learn. I was super tempted to give that a try, but then the shell is one of those things that I don't really want to mess with right now, because I feel like it's gonna um like trying to change that is gonna mess with a lot of other integrations that I have. Anything that is assuming that I'm using bash, it might break. And then I'm gonna have to go and fix a bunch of things in a bunch of different places. I'm gonna have to mention that, oh yeah, I'm not using bash, I'm using fish. And that kind of seems like I'm just inviting problems, if that makes sense. All of the other tools that I'm using, I'm super happy to use those tools, because they're actually gonna, benefit me. Give me a second here. Yeah, I'm super happy to use those tools because they're actually gonna benefit me. But in this specific case, it kind of seems like the benefit that I'm gonna get from, switching to a different shell is probably gonna come with a lot of downsides, a lot of headache that I don't want to take on. Okay, then the shell, a program that listens for text commands and interprets them, like finding where Git is installed, and asks the OS to run them. And then you have the program like HTOP or Neovim. That's the actual task you want to perform. How they run without the middleman. The operating system, the kernel, is the one that actually starts processes. Okay. While the shell is the most common way to request a process start, it isn't the only way. WezTerm is a program itself. It has the power to say to the operating system, hey, instead of starting zish inside this window, please start btop directly. The OS doesn't care if the request came from a shell or directly from the terminal emulator. It just sees a request to start a process, assigns it a PID, and connects its input slash output to the WezTerm window. Okay. Um, with a shell, Oh, that's an analogy. All right. Why use one over the other? Running through a shell, which is the default, the pros are you get shell features like aliases, environment. Oh, okay. All that is part of the shell. Oh, and the ability to run multiple commands in a row. Okay, okay. The cons are a tiny bit more memory usage, which is usually negligible, and one extra layer of complexity. Running it directly, the TUI way, the pros are it's extremely fast and clean. If you want a dedicated window just for monitoring your system, you don't need a shell sitting idle in the background. The cons are as soon as you quit your program, the chef, okay, that's the part of the analogy, leaves the table. And since there's no waiter, oh God, let me read the analogy, dude. Holy shit. Okay, comparison, the restaurant analogy. T you know what? Wait. Um, uh, can you rewrite um, the second half of your reply without an analogy? Okay, in technical terms, the difference lies in the parent process and how the terminal handles the communication system. Indirect execution, which is the shell method, okay, WezTerm, shell, so on. So when you open a standard tab, WezTerm executes the shell as a child process. The shell then stays active, waiting for your input. Environment. The shell performs expansions like turning the tilde. Um, that's the tilde thing, right? Yeah, yeah, that's the tilde. Okay, turning the tilde into slash so and so, so and so. Right. Okay. It's basically I don't know if that's gonna happen here. Would this work? Yeah, so that expanded. Um, how do I? There is a way to do this. Hold on. Yeah, no, I'm running into an issue here. I forgot. Okay, so what I'm doing here is I'm basically getting this to be parsed and run or expanded. I don't know why that all of a sudden got stuck, but yeah, I'm getting this to be expanded before the oh, you know what might be happening? So it's expanding, and I think it might be running then. So if I, let's say, do this, yeah, no, hold on. If I put it in here, if I do something like this, um, and I echo this, then yeah, this is what we get. Sorry, this is a horrible way of showing this, but like, this is one way of using this thing. I've used it in the past where I needed to get a certain um where I needed to get the path of something. I think I was using which maybe. So I had to wrap that up into something like this. So if I did something like this, which let's say which I don't know, UV, and that's going to return a path, right? And then I want to echo that, then I can do it like that. There was certain, or there was one like very specific thing that I had to keep in mind. I can't remember what that was, and that's kind of why I was running into that issue previously, where I tried to do this thing and I got that error. I think it's the enter key. Yeah, I think it's the enter key. So this expands and then it's trying to run that. But then if I echo this, this expands into that. Yeah. Okay. 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 You know what? Okay, I'm gonna step away from this right now. Um, for now, we are gonna jump back into. Hold on. Which one was it? Was it here? I think it was here. Yeah, yeah, it was here. So we are gonna jump back into Neovim, and I don't remember what the last thing was that I had opened. Oh, it was this. Okay. All right. Great. So hold on just a minute here. Okay. Okay. All right. We are gonna jump back into, before I get distracted again, we're gonna jump back into um this. So what section were we in yesterday? I don't think we were in peripherals. We were still in main, weren't we? No, we got done with no main. Yeah, yeah, we got done with no main. Um, Now we have to actually do something with, our working program, because so far the thing the thing compiles, the build succeeds, but that's about it. We aren't actually doing anything with it. Yeah, it's saying that here as well. Um, Not quite. We've crossed half the stage. Uh, we now have a valid binary ready for ESP32, but there's more to do before we can run it on real hardware. Okay, cool. Give me a second here. We seem to be dropping frames. So I need to fix that by reducing the load on my connection. So just a minute here. I'm going to let this stabilize. Okay. All right, let's continue reading. Okay, peripherals. Before we move on to the next part, let's quickly look at what peripherals are. In embedded systems, peripherals are hardware components that extend the capabilities of a microcontroller. They allow the MCU to interact with the outside world by handling inputs and outputs, communication, timing, and more. Okay, okay. While the CPU is responsible for executing program logic, peripherals do the heavy lifting of interacting with hardware, often offloading work from the CPU. This allows the CPU to focus on critical tasks while peripherals handle specialized functions independently or with minimal supervision. Offloading. Yeah, I didn't understand what exactly it meant by offloading, because all I'm thinking about is like it's sending signals to, like, external devices. So like when you, for example, are interacting with some sort of display, then you're giving it signals over some kind of protocol. And yeah, I haven't, like, I'm thinking about offloading in that manner. And it's also being mentioned here, like there's mention of UART, there's timer and PWM and stuff. I think I'm on the right track with what I'm assuming there. Hold on, let me open up my stream chat now that the connection has stabilized. Okay, all right. So, uh, wait, I have a simple food related question for Gemini that I need to clear up before I forget it. Um, okay, hold on. Hold on. I'm still trying to. Oh yeah. Okay. Sorry. This is there's like a whole lot of dead air going on here, but just give me a second. And so sometimes the okay. Okay. All right. Sorry about that. We are getting back. So, um, okay, offloading. Offloading requires to refers. Okay, I was confused for a second. Okay, offloading refers to the practice of delegating certain tasks to hardware peripherals instead of doing them directly in software via the CPU. This improves performance, reduces power consumption, and enables concurrent operations. For example, a UART peripheral can send and receive data in the background using DMA, while the CPU continues processing other logic. A timer can be configured to generate precise delays or periodic interrupts without CPU intervention. A PWM controller can drive a motor continuously without the CPU constantly toggling pins. Okay. Offloading is a key design strategy in embedded systems to make efficient use of limited processing power. All right, common types of peripherals. Here are some of the most common types of peripherals found in embedded systems. GPIO, okay, UART. Should we read this entire thing? Yeah, let's read the entire thing. GPIO, digital pins that can be configured as inputs or outputs to interact with external hardware like buttons, LEDs, and sensors. UART, serial communication interface, used for sending and receiving data between devices, often used for debugging and connecting modules like Bluetooth. SPI, high-speed synchronous communication protocol used to connect microcontrollers to peripherals like SD cards, displays, and sensors using a master-slave architecture. I2C, um, two-wire serial communication protocol used for connecting low-speed peripherals such as sensors and memory chips to a microcontroller. ADC, which converts analog signals from sensors or other sources into digital values that the microcontroller can process. PWM, I'm surprised they didn't mention the DAC. Okay, anyways, PWM generates signals that can control power delivery used commonly for LED dimming, motor speed control, and servo actuation. Then timer, used for generating delays, measuring time intervals, counting events, or triggering actions at specific times. And RTC keeps track of current time and date even when the system is powered off, typically backed by a battery. Okay, all right. Okay, peripherals in Rust. In embedded Rust, peripherals are accessed using a singleton model. One of Rust's core goals is safety, and that extends to how it manages hardware access. To ensure that no two parts of a program can accidentally control the same peripheral at the same time, Rust enforces exclusive ownership through the singleton approach. The singleton pattern. The singleton pattern ensures that only one instance of each peripheral exists in the entire program. This avoids common bugs caused by multiple pieces of code trying to modify the same hardware resource simultaneously. All right. In ESP-HAL, peripherals are also exposed using the singleton model, but we won't be calling peripherals.take directly. Instead, we will use the ESP-HAL init function. This function takes care of basic system setup and internally calls peripherals.take for us, so we get access to all peripherals in a safe and ready to use form. Awesome. Okay, initialize ESP-HAL. Okay, we were able to successfully prepare a binary for the ESP32. However, the program does absolutely nothing at this stage. Let's bring it to life by Dude, can I just say, I've mentioned this before. I am excited to get into this tutorial, go deeper into this tutorial, not only because it teaches you about um, doing how do I say this? Like, not only because this um, runs you through a bunch of examples, but it's also teaching you like the basics. First of all, it's teaching you the basics of like microcontrollers, very general microcontroller concepts. Then it's teaching you about like boilerplate code within the microcontroller, within like a basic microcontroller project, and it's explaining what each of those lines of the boilerplate code do. Because like a bunch of these things, even initializing this clock, this is part of the boilerplate code. So like, holy shit, dude, I really appreciate the people who have taken the time to build this documentation and who continue to work on it. I'm guessing because I believe they are actively working on this. Give me a second. Let's open up the repo real quick and see. Yeah, this is actively being worked on. Yeah, dude. Shout out to the contributors here. Okay. All right. Um However, the program does absolutely nothing at this stage. Let's bring it to life by replacing the same Blinky program we saw in the quick start section. Start by adding this import. All right, let's do that. Use ESP-HAL clock CPU clock. Now at the beginning of your main function, add this line. Okay, let config equals ESP-HAL config default what is going on here? Okay, whatever. Default dot with CPU clock, and within this we want to do CPU clock max. What does that do? Oh, it's like a max clock speed, max frequency. Uses the highest possible frequency for a particular chip. All right, great. This line creates a default configuration for the HAL and sets the CPU clock to its maximum frequency. You can think of it as giving the chip some instructions on how fast it should run. We are telling it to run at its maximum speed. All right. Um, initialize peripherals. Dude, I'm gonna need to remember to unplug this because I don't know if running it at its maximum speed is gonna cause some sort of heat up later on, because I usually just leave this ESP32 plugged in for a good couple of hours after I'm done streaming, because I'm like, at some point later, I might be looking into, some ESP32 stuff, so I don't want to have to connect the thing again. Eventually, I do disconnect it before sleeping, but I usually leave it connected. Now that I'm setting the clock speed to maximum, I need to look into like whether that could cause a heat up or something over time. Okay, initialize peripherals. Next, we initialize the peripherals using the HAL. Um, so we do let peripherals equals ESP-HAL init config. What did we call this thing? I think we called it config. Yeah, we did. All right, great. So far, no errors. This function sets up the system by configuring things like the CPU clock and the watchdog timer. After that, it gives us access to the CPU. It gives us access to the chips, peripherals, and clocks, so we can start using them in our code. All right, LED. The next step is to configure the onboard LED of the DevKit V1. I don't know if that's going to be the same as what I've got. I believe I do have an LED there. I don't remember which pin it is for. Um, let's see. Let's see. Maybe I can get the. I can just take a guess. Okay. The next step is to configure so and so. How are we going to find it? For that, we need. How are we going to do that? Not find it. For that, we need to control a GPIO pin. GPIO stands for General Purpose Input Output. These are pins on the microcontroller that can either read digital signals input or send digital signals output. Want to read a button? Use GPIO as input. Want to turn on an LED? Use GPIO as output. Want to talk to a sensor or control a motor? GPIO pins are the starting point. GPIOs are the most basic and most essential way your program talks to the outside world. What pin is the onboard LED connected to? If you are using a bare ESP32 chip, there's no onboard LED, but we are using the ESP32 DevKit V1 development board. On this board, the onboard LED is GPIO 2, so that's the pin we'll use next. Initialize the LED. To control the onboard LED, we configure GPIO 2 as an output pin. Adding this necessary import Oh, add this necessary import. Why am I saying import? Import. I mean import. For some reason, I was saying in instead of im. Anyways, ESP-HAL, GPIO. There's probably a different way to write this. Yeah, GPIO, level, output, and output config. And then down here, we can write time and duration and instant. I'm doing it in this way because like it's gonna get it's gonna get changed anyways, even if I did write it in a separate way, even if I did write like as separate statements. I'm guessing in this tutorial it was done like as separate statements just to make things less confusing. Oh, I could also um add these. So it would be main and peripherals. Let's save that, and then we can delete this, and we're good to go. Yes. Okay, add the following line inside the main function. Okay, let mute LED equals output new. We have to pass in peripherals dot GPIO2. Does it mention like LED or something? No, never mind. GPIO2. I was assuming there might be like, they might have set some sort of constant, and based on what chip you are using or what. Oh, actually, it's the chip, not the dev board. Yeah, okay, okay. No, it's talking about the chip here. Um, the LED connection is more about the dev board and less about the chip. Okay, output config default. Okay, the peripherals.gpio2 part gives us access to that GPIO2 pin. We set its initial state to level high, which turns the LED on. Hold on, where was I? Which turns the LED on. The output config default uses standard settings to make it an output pin. Note here, we mark the LED variable as mutable because we will change its state later. We can use the toggle function to switch the LED state between high and low, allowing us to blink the LED. Okay, in the main loop continuously toggles the LED state using a simple approach. We call the toggle method on our LED output pin, which switches it between high and low states. Between each toggle, we introduce a 500 millisecond delay to create a visible blinking effect. Okay, led.toggle. Oh, there's a separate function, blocking delay. The blocking delay function provides a simple timing mechanism by busy waiting until the specified duration has elapsed. It captures the current time and continuously checks if the time has passed. Okay, we don't need to put this into a separate thing. We can just do let delay underscore start equals instant now, and then while delay start.elapsed is less than duration. So we're going to set a duration of, what's this supposed to be? What is elapsed? Okay, that is delay start.elapsed. Yeah, elapsed in what? Returns the elapsed duration. Okay, it's returning a duration. Dot as milliseconds. This is a reference, right? So we should be fine to read this. Okay, all right. So here, we do that. Oh, we don't do that. We do that. And here we're supposed to do dot as milliseconds. And then we do 500 milliseconds. So less than 500. What's this returning again? U64. Do I have to like explicitly typecast? No, I think we're good. Okay, so here we're just waiting. We're not doing anything more. Okay, all right. Okay, the blocking delay function provides a simple timing mechanism by busy waiting until the specific time duration has elapsed. Um, this is basically like the well, kind of in a way. I was about to say that it's similar to how we would set rates like in Unity when you want to set up a fire rate or any rate of some sort, like you some action is happening and you want to give it a certain speed, but then within Unity when you're scripting within that whole system, you're usually operating either within the update loop or sorry, within the update function, which is constantly being called depending on the frame rate. You're either going to be doing it there or you're going to be doing it in fixed update, which is, so update is called once per frame. Um, from what I remember, yeah, update is called once per frame, so it's frame rate dependent. Fixed update is called at fixed time steps, so it's not frame rate dependent. And generally, you want to use fixed update for physics related calculations. Okay. Um, so the way that we would introduce a rate in there is we would set up a timestamp, and the first time that we run it, so the timestamp will be 0, and we have access to elapsed time. So what we do is, given our rate would be, that's in seconds usually, or could be milliseconds as well. It's one of well, okay, so we specify it as, because the calculation is simple on this end. Let me show it here. So we do something like let rate equals, I don't know, 0.5, so half a second, right? And then let um, timestamp equals 0.0. So this is going to be, it's going to start at 0. Okay, and then we have elapsed time. This is going to be constantly changing. This is going to be constantly increasing, and this will be given to us by the engine itself. So what we do is every update, we check if elapsed time. So whenever the user wants to take a specific rate limited action, then we check if elapsed time um, is greater than the timestamp. So the first time, yes, it's going to be greater than the timestamp, right? Okay, great. It's greater than the timestamp, meaning that action can be taken. So we take that action and then we set the timestamp's new value to be elapsed time, um, elapsed time plus the rate. So basically whatever the current time is where the action is being taken, and then plus the rate. So then we can, if we set up like, let's say, I don't know, 5.0, the user can only take that action every 5 seconds. So yeah, that's what I was kind of remembering that by looking at this calculation. Okay, final code. Here's a final code. Okay, great, awesome, cool. Um, we've used a slightly different approach here. We've just basically put this code directly into the loop. We're not uh, we're not doing like a separate function thing. Should be pretty much the same, right? Because the function doesn't return anything. All it does is take in a duration, which yeah, it takes in a duration. It initializes instant, which is it's a type instant, returns the current instant. The counter won't measure time in sleep mode. How are we getting? So instant.now.elapsed. Elapsed is our duration. Okay, I was trying to make the connection of duration in here somehow, but that usually only happens once you call elapsed. So I'm guessing instant has like a bunch of other stuff as well. Compares and returns a max of 2 values. We have elapsed, we have duration since epoch, which is interesting. Wait, the epoch here is the boot, so returns the elapsed duration since boot. So then what's the difference between elapsed and duration since boot? Oh, this returns the elapsed duration since instant was created. That's interesting, dude. Okay, I didn't know that. I was assuming elapsed is like, yeah, okay. No, that makes sense because like, okay, my initial assumption was wrong. My initial assumption was that it's elapsed, like total elapsed time, right? But then if we really think about that, this logic wouldn't work if that was the case. Because like it would work for the first half a second, but then after that it wouldn't work because this condition wouldn't be true anymore. So that makes sense. That makes sense. All right. Okay. So we save this, and then what? Linker script. Did you try to build your project again? Yup, it no longer compiles. So what happened? Let's do that. Let's fail and see. All right. Could not compile so and so due to one previous error. What exactly is the error being shown? I see LD. Yes, it says LD return one exit status. So LD is our linker in this case. I should look into how I could get it to use mold, because I do have mold set up as like the default linker. Um, is it in cargo? Cargo, not crates, config. Yeah. Wait. Oh yeah, I have wait, the linker is clang. I thought the linker is mold. No, mold is the linker. I'm guessing clang because the Rust toolchain calls clang. So clang then no, Rust toolchain doesn't call clang. Rust toolchain by default it was calling GCC. And then GCC does the compilation and subsequently calls the linker. So in this case we are using clang instead of GCC. And we are using mold instead of LD. And then clang, for some reason it's being mentioned as a linker here, which I don't get. I'll have to look into that. But yeah, mold is our linker, which is apparently a much faster linker. Yeah, okay. All right. Okay. The problem is the linker does not know. Sorry, I'm doing that finger popping kind of thing. Yeah. The problem is the linker does not know how to lay out your program in memory. Embedded systems like the ESP32 don't have an operating system to handle memory, so we must tell the linker exactly where code, data, and stack should go. To fix this, I'm glad that I learned assembly because this stuff, I really feel like it wouldn't make too much sense to me if I hadn't taken the time to learn. Holy shit, I've mentioned this before. Learning assembly has benefited me in more ways than one. It is it is insane. It is insane. Learning assembly taught me way more than just assembly. Like way more than just assembly. It's crazy. Anyways, to fix this, we provide a linker script. This is a simple text file that tells the linker things like where to place code in memory, where the stack starts, how big each memory region is, and so on. The linker script we will use is called linkall.x. This script is provided by the ESP-HAL. It contains memory layout settings suitable for the ESP32. Cargo config. We can update the cargo config.toml file with the following lines to fix the issue. However, we will not use this approach. Instead, we will use the build. I was wondering when the build.rs file is going to come in. Instead, we will use the build.rs file. Okay, so what it's saying is that we could do this, which this is what does eventually end up happening, because if we come here and take a look at cargo config. No, it's not here. Where was it? Wait, am I mistaken? Oh, wait, that's cargo config. It is probably, it's either under config or under cargo toml. One of these two. Give me a second. This thing is frozen. Okay, yeah, this is frozen. Let's do it from here. I don't remember. I think it might have been in this. Yeah, I think it's in config, but then okay, I'm not able to remember it. Oh, could it be in like the build rs thing? Possibly. I'm not sure. I can't remember where exactly I had seen it, but yeah. Anyways, okay. So don't add the linker argument in both cargo config toml and build rs. It'll cause a conflict and result in a build error. Use only one method. The ESP generate tool adds this line to the build.rs file. It also does a few more things along with it, which we will not be covering here. To match that structure, we will also add the linker argument using a build.rs file. I didn't get that last sentence. To match that structure, we will also add, oh, to match the structure of, that's a good idea. Okay. To match the structure of, um, an ESP generated project, we'll be using the build.rs thing. So we need to create a file named this in our root. Yes, this is our root. So we do build.rs, and here we do main, I think fn main. Yeah, fn main, print line, cargo, rustc. I kind of have to operate blind here because IntelliSense is not working here. So I'm kind of interested in understanding how all of this is working exactly. Like how this separate linker, how the separate build script gets used. In general, I guess I want to know how build.rs gets used, because I think this might be a general Rust thing, build.rs. It might be like a, or it could also be that something in the toolchain is configured to use a build.rs file. I'm not sure. I guess we can do research on this. Okay, now do cargo build. Hell yeah, dude. Okay. Okay. Success. Application startup flow. Dude, you know what? I think I'm going to keep this for tomorrow. As much as I want to continue, I could have gone for the next 45 minutes, for like another 45 minutes, I mean, but I have some food on the stove and I kind of need to finish some preparation before the next 45 minutes. Um, so I'm going to pause this here. I'm going to end the stream here and I will carry on with this tomorrow. Yeah, so I'll stop it here. We're going to pause here and continue tomorrow. I'm going to go back to doing WezTerm stuff, learning WezTerm stuff, because I'm now slowly moving my setup from Kitty plus Tmux over to WezTerm. I still haven't gotten to the multiplexing part. I also still haven't gotten to the SSH part. I need to work on both of those things. And then once both of those things are set up, and once I understand the whole multiplexing side plus SSH side of WezTerm, then I can confidently move my entire setup from Kitty plus Tmux to just WezTerm. There's a lot to explore in WezTerm because this is, holy shit, dude. This is it's a pretty, I guess the best term to use here would be versatile application. There's so much that you can do. Um, and it's kind of wild how there's a bunch of functionality that's hidden away um, until you configure WezTerm to actually use that functionality. That's kind of crazy because that, I feel like that's one of those things that kind of forces you to um, learn about the configuration. Yeah. So this is like one of those interesting things where in order to use this terminal, I mean, you could use the terminal as is. I personally wanted to make it look exactly like how my Kitty terminal looked. I wanted to install the theme. I wanted to have like very specific aesthetic, and I didn't like the aesthetic that was like the default aesthetic. So I wanted to customize things, and that's why I had to learn a bunch of these things. I'll give Kitty this. It is much less, it's much more frictionless to get started with it. But to be fair, over time, there have been certain things that I had to customize in it. So it's not like it's completely, that I didn't have to customize Kitty at all. Because I did have to select the theme, which fortunately they have like a theme selection thing for it. Is this a good place to show it? I don't know. Kitten themes? Yeah, this is the entire, these are all the themes that they have. You can also like do, based on dark or light, or in my case, like recent, because I use Rose Pine Moon. Um, you can search for various themes. They have a bunch of different themes available. So, like I said, in my case, it was Rose Pine Moon that I wanted. And that's what hold on. Why is it not letting me search? It should be accepting the, hold on. What if I do it from here? Oh, okay. No, from here also it doesn't work. It says search is slash, which usually works. So you can like search for a specific theme in this very, very long list. You can search for your themes, but like for some reason it's not working here. I feel like that has to do with me being within Tmux. I'm not sure. Either way, That's it. So, okay, all right. So that's gonna be it for today's stream. I'm gonna continue working on ESP32 stuff tomorrow. We're gonna pick back up from where we left off, which is here, application startup flow, and we're gonna be going into the bootloader thing as well, which should be interesting. So yeah, tomorrow should be very productive. That being said, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.